Okay, well, good morning, everyone. I am going to be recording the presentation this morning so that we can share it with those that were unable to participate live. The session that we've organized this morning for you is SDN and NFV, titled Hype or Reality. And so I know all of us have heard a lot about software-defined networking and network function virtualization, unlike the network file virtualization that was in the invitation for those of you who got the earliest version of that invite. But the question is, are these new technologies really ready for prime time? So what we're going to talk about this morning are Brocade solutions, and our speaker, Matt Davey from Tallac Networks, has some very interesting applications that we'll be demonstrating for you that show that SDN and NFV really are reality today. So the future of networking is here, and to show you that reality is Matt Davey. So Matt, I'm going to turn it over to you and let you introduce yourself to the audience and go through the presentation.
Okay, thank you very much. Can you hear me okay?
Yes.
Excellent. Thank you very much. I'm excited to have you all here. I'm very excited with what we're going to show you today. Just a little introduction on myself. I'm one of the co-founders and the solution architect at Tallac Networks. I've been in the industry a long time now, mostly as a network engineer, network architect, starting out with large carrier networks. Spent a lot of time at Indiana University doing very large enterprise networks, as well as the Internet 2 nationwide network. I've been doing this SDN thing for a long time now. I led two of the very earliest production deployments of software-defined networking, one of them in a data center, and the other being the Internet 2 deployment, which I'll talk a little bit about more in a bit. And I started one of the first SDN interoperability lab in center at Indiana University. So I've been doing this a long time. I've seen this come from a research project at Stanford all the way through, being reality and getting actually to see products and full-fledged solutions deployed and in production with customers, which has been a lot of fun. So I want to share a little bit with you about how that's happened. I think a lot of us know the typical Gartner hype cycle here. As I said, I was involved in this actually as early as 2008. Watched this with the first OpenFlow release in January of 2010. There was a lot of hype that happened over the following 3 or 4 years, all the way from the first interop in 2011, where it made a huge splash, the Google announcement, I think everyone remembers, in 2012, and really peaked, I believe, around the Nicira sell in 2012. Around that same time, shortly after that, we did the first deployment on Internet 2 on the Brocade MLX, which is full OpenFlow deployment, nationwide network, all sorts of production traffic based on that. That was a whole lot of fun, a very great project to work with the Brocade team on. But at that point, I think the industry got down to, okay, how are we going to put this into the hands of mere mortals and build real solutions that are valuable to customers around that? And a lot of that, in my opinion, has been focused around the Open Daylight project, which I'll talk more about in a bit. It's sort of the center focus of that. Open Daylight was formed in April of 2013. Their first release was not quite a year later, in February of 2014, and since then they've done a release of Helium. In fact, a release 2 of Helium recently as well. Other thing I wanted to point out is this AT&T blog post. You see the link down at the bottom. They've made some statements lately very clearly saying our direction is network functions, virtualization, software-defined networking, automation. In this blog post, they make a commitment they're going to transition 75% of their overall network by 2020, make some big steps towards that in 2015. So I think you're seeing it getting really to reality. And just this month, last month actually, Brocade released the Brocade Viata controller, which is a commercial distribution of Open Daylight. very focused around the open source and driving innovation back into the open source platform, supporting that, supporting developers as a whole product and set of solutions and services around the Open Daylight Controller to help organizations implement and build applications and do development around the Open Daylight Controller. So I think we're seeing that really hit the mainstream and get into reality and real networks. I think two kind of key factors about Open Daylight I want to point out. One is the membership. I pointed out the Platinum members here. It is all the big players in networking, and it's not just there in name only. I believe the contribution for a Platinum member is in the neighborhood of $500,000 a year. If you add that up across 11 members, there's a lot of development going into this platform. It's really amazing the level of contributions that are going in, and really the pace they've been able to keep up and roll out high quality software at a really amazing pace. The other kind of key piece is the architecture, and it's really around modularity. The ability to support multiple southbound protocols and sort of abstract that away from the northbound protocol and present interfaces to build applications on. And this is really a key to the success of Open Daylight. It's a key piece of being able to do what they've been able to do with that controller. So, Open Daylight, in my opinion, it's there, it's in production. We've had it in production with customers for nearly a year now at this point in production networks, and it's reality. It's there. People are using it. We're using it. It's deployed and it's ready to go. Is the key message. One thing I want to focus on is really SDN for the enterprise. It really started there. If you look at Martin Casado's work at Stanford early on, it was very focused around the enterprise. It gained a lot of traction early on in the data center for a lot of reasons. We're now seeing a lot of press around the big carriers, whether it be AT&T or Verizon, Deutsche Telekom, NTT, etc. But there's a real application for the enterprise here. That is our focus at Tallac and what I want to show you today, and how there are real solutions both for SDN and NFV applied to the enterprise. So that we see two kind of ways that SDN is applicable to the enterprise. So when you say, what does this give me? What do SDN and NFV give me in the enterprise? There's two things. One is we see the value of SDN goes up with scale, right? The larger and larger network you deploy, the more value there is to software-defined networking. It's obviously why it originally picked up networks like Google or Amazon or Microsoft, and these massive scale networks, thousands and thousands of switches and virtual switches they need to manage, and it became very obvious for them that this was a way they had to automate to survive. So we see the same thing in the enterprise, and we see the key areas for automation. Zero-touch provisioning, right? You want to put a switch or a router or an access point into the network, and you don't want to have to touch it. You want to fully automate the bring up of that device without having to touch it. When you want to do large-scale updates, if you have thousands of sites or you have thousands and thousands of devices, and you want to update those, you really need to automate those updates or changes. And you also want to automate common break-fix tests. We've been doing this for a long time in the sort of managed desktop space. If you look at that, there are lots of tools out there in the managed desktop space for finding particular problems in desktops and auto-remediating those problems. We want to be able to do the same thing in the network. And the benefits are obvious, right? You lower your OpEx, you get higher reliability because you are automating that. There's no human, no error between the fingers and the keyboard, and you reduce your time to production. You can bring up new services faster because there are no humans involved in making that happen. So if those are the areas that SDN has value, where do you find those in an enterprise campus scenario? And we see those in two places. One is branch office, and we're seeing a move of SDN into the branch office now. There are lots of organizations with hundreds, if not thousands, many thousands of branch offices. It's very ripe for the automation and value of SDN. The other place we see it is in managed services. So you have managed service providers in various verticals, whether it be hospitality or education or small business, that manage networks for lots and lots of customers. They have thousands of sites out there, or hundreds of sites of customers, and they're seeing the same issues of how do I automate at scale to grow my business to larger and larger numbers of customers. So those are two big areas. If you look at the enterprise campus from a scale perspective, SDN makes a lot of sense. The other area where SDN makes sense is in terms of integration with business workflow or business applications. So what do I mean by that? So if you look at most businesses, they have various business applications, and on the back end of those are a set of databases. If you're in hospitality or you're in, say, apartment complexes, multi-tenant dwellings, you have a property management system. If you're in K-12, you have a student information system and a learning management system. If you're in a business scenario, you have an HR database, you have social media, you have various different things, customer loyalty databases in a retail setting that they drive applications to the customer on. And what we're talking about, SDN allows you to bring the network as a resource and integrate it with the workflow and integrate it with those business applications to bring new value to the customer. And I think we've heard a lot of talk about this over the past couple of years in the industry, but we haven't really seen a lot of great examples of that. We have examples in production with customers today that really show that. I'm going to show you one of those in depth today. We have actually 3 up and going in customer sites today. What I'm going to show you is what we call our school or our classroom application. This is an application meant to be delivered on a tablet, used by the teacher, used by the students, to allow the teacher to control and direct use of internet resources in the classroom, to monitor on-task performance of the students, to facilitate group learning, to do things like collect attendance and grab statistics about where students are going, all sorts of things like that. It really ties into student information systems, learning management systems, other tools that the classroom uses, and becomes really the central workflow tool for a teacher in the classroom. The second one, which I'm not going to show, is a retail application, more focused on a storefront or a restaurant, to look at visitor metrics for traffic conversion, ties into customer loyalty databases, things like that, to really drive business in a retail setting. So these are applications built on top of an SDN platform that then tie into other resources and become a workflow tool for the business. So those are the two areas: scale and integration with business resources, workflow applications. Those are the two areas I think that are going to be really key to looking at SDN and NFV in a enterprise campus scenario. Really quick, some background on Tallac and on our team if you haven't heard of us. We're a startup, been around a little over 2.5 years now. Have a core team from HP Networking, that came from HP Networking. Bill Johnson, our president, was the head of worldwide R&D for them. Paul Congdon was their CTO of networking for many years. So when I was at Indiana University, we were one of the biggest customers, deep engineering relationship. I worked very closely with the rest of the team, the whole core team together for 20 or so years. Another set of the team come from a Cisco background, a number of successful startups under our belt. So that's the core team and the company. Quick overview of the solution and what ties this all together. I'm going to be demonstrating this for you in just a few minutes. There are really 3 pieces to what we're doing. We are a software company. What we build is software. So we have a cloud software platform. If you're familiar with a Meraki or an Aerohive, we do cloud management of devices, lots of similarities to those other products, both wired and wireless. We do some things fundamentally different in which it's based on SDN from the heart, built from the ground up. What that does is allow us to integrate with these SDN applications, as I mentioned earlier, and you'll see a demo of how that's done, and adding SDN apps to those networks. And you'll get a preview today of the third piece that's rolling out actually as we speak, which is the virtual network functions or virtual network services integration. And I'll show you in just a second how all this goes together, but ultimately cloud management across and orchestration across all 3 of those pieces. So I'm going to get into the demo. I suspect there will be a lot of questions as we get into the demo. I would ask that you hold those questions to the end. There's a number of things I want to demo. I believe we have this open for well, for as long as we need it, actually. I can stay for at least a half hour after the hour mark. If there are questions, I'll be glad to go into depth on those and answer any questions you have. I'm going to go through the demo. Please take note of those and bring those up at the end. So the whole idea is I want to demo how we integrate with Brocade and the components of Brocade, and show you really three pieces here. This is the overall solution. As I mentioned, there's a cloud portal piece in the middle. We can do cloud management of physical devices. I'll show that to you in a second. We have SDN applications. We built an Open Daylight cluster that runs in the cloud. It runs on Open Daylight Helium SR2 release. Brocade's Viata controller. It's identical from software to Brocade's Viata control. In other words, all of this will run on Brocade's commercial distribution of ODL. So that's sort of one integration point here. We've added some pieces to that. We've built out some scale-out clustering mechanisms, as well as a virtualization layer, which allows us to deploy multiple applications for different tenants on top of the same controller, as well as some components for orchestration of that whole stack. So that's one piece of how we do the app integration. On the other side, we're going to talk about virtual firewall, and on that side, the integration point is the Brocade Viata vRouter. And so I'll walk through this demonstration, and then I'll actually do the demonstration so you understand what I'm doing. So from the cloud portal, you can go in and actually configure a virtual network. And so this is one of the kind of key differentiators of what we're doing on the cloud side. We've actually created a virtual network abstraction for the campus LAN. So if you're familiar with, say, OpenStack Neutron and the kind of logical network abstraction that Neutron creates for virtual networks in the data center, we've done something very similar for the campus LAN. So in addition to just being able to manage cloud-managed devices, on top of that cloud manage as a device, instead of having to go in and configure all those devices to create a network service or a virtual network for your customers at that site, we have created an abstraction on top of that, akin to the Neutron abstraction in the data center, that allows us to define a virtual network in the cloud, independent of the physical network, and to push that virtual network to different physical networks. So I can define one virtual network at a logical layer, and then simply say apply that virtual network to branch 1, apply it to branch 2, apply it to branch 3 if I want to do that. So that virtual network abstraction is very key. Once you have that and you have the appropriate APIs to that, then adding in these other components becomes very simple. So what I'm going to show you is how you create that virtual network, how you push that down into different networks, different customer sites. And then from that same cloud portal, how you can orchestrate turning on a new app instance. I'm going to show you the guest management application and tie that instance to that virtual network. So that is controlling all the traffic on those virtual networks across the sites. So that's sort of the first piece. And once you've abstracted out this this cluster over here, and you've abstracted the virtual network, the key about from the cloud that's very cool is it makes it very easy then to orchestrate those pieces and tie them together. You're not going in and downloading an application, installing that application on your controller, configuring that application. You don't have to go in and configure a virtual network in the campus, configure that virtual network to point to the appropriate controller, because the cloud knows about the virtual network abstraction and it knows about this SDN application abstraction. It does all of that for you. I think you'll find that pretty cool. Also, once I have that virtual network abstraction, then I can tie in virtual network services like firewall. So I'll show you how we can use a cloud orchestration API like AWS or OpenStack. In this case, the demo will be done on AWS to turn up new third-party network functions like the Brocade Viata router, and then tie those together to virtual networks in the customer site. So in this case, what I want to do, we have a number of examples of this in production. Chiropractic clinic we have in California comes to mind. I have 3 sites. I want to put a corporate SSID at each of those, a VNet there. I want to create a multi-site VPN where each of those sites is layer 3 VPN or layer 2 VPN together, but yet they all share a common firewall and exit to the network, to the internet through a common connection. So single firewall covering 3 different sites with VPNing the sites together. And so that's the second piece. And then for the third piece, I'm going to dive into the education app and show you just the kind of business integration that you can do with an application like that. So that's the setup for the demo. So let me go ahead and jump into the demo. Let me come over here. Okay, so what you see here, hopefully everyone can see my screen. Please yell if you cannot. What you see here is the cloud portal. This is, I'm logged in as this demo account. It's set up as a managed service provider. I have 5 demos customers set up in here. Here you see a chain of the 3 what I call demo clinics. I also have a cafe that is set up in here as well as another demo. So I can come in here. You see here it does all the standard device management you would expect from a cloud management solution. I can see my list of devices here. You see I have 1 access point. I can change radio settings. I can look at logs for that device. Utilization, client data. I can look at all kinds of things across the site. I can go in and configure, upgrade the firmware, all the configuration, all the managing inventory and other user accounts and whatnot. The key that makes this difference is everything here has a REST API behind it. Every single aspect of this has a REST API that's exposed to customers and partners. So I can drop down into that REST API right from the user interface and get all the documentation. Right? So if I want to get a list of all my venues, here's the REST API for that. I can actually try it out, and you can see all the JSON formatted code that comes back when I do that. If I want to grab a list of all my access points at this site, I grab the site ID, I go up to my access point API, I drop the site ID into the access point API, and you can see, yes?
I'm sorry about that.
No problem. So I've dropped my site ID into my access point API, and you can see all the gory details about the access point. So everything you see in this cloud interface has an API behind it. And that's sort of the key, as well as this virtual network abstraction. So in this case, I have Wi-Fi only sites. So my virtual networks, the sort of user-facing part of the virtual network in a Wi-Fi only site is the SSID. You can see I have some configured here. These are just set up for guest access. So I want to show you how I can create a new virtual network and how I apply SDN applications to that. So I'm going to go to this. This is actually a great French restaurant that I go to here in town. I'm going to go in. You see I have no virtual networks configured. I'm going to configure a new one. I'm going to just call it Petit Cafe. I'm actually going to configure it as open authentication because I'm going to add a guest management application from a third party that provides captive portal authentication for this. So from this perspective, I'm just going to set it as open. I'm not going to go through all the options, but here we have a concept of a backhaul for the virtual network. And these tunneling mechanisms, open standard tunneling mechanisms, are key to how we integrate into those virtual resources back in the data center, whether it be a firewall or content filtering or what other mechanisms you have back in the data center. These are all key to getting those tied back either in an encrypted or an unencrypted tunnel in standard format. So I'm not going to use a backhaul. I'm just going to drop it locally on the network. And now I've configured a virtual network that within a few seconds will be pushed out to the APs that sit behind this site. So now that I have a virtual network, I'm going to go over to another portal we have, which manages the SDN applications. You can see I'm logged in with this same demo at Tallac.com account that I am over here. The account systems are integrated. It's all the same system. It's just a different interface to present to manage the applications. So I'm going to come into my demo managed service provider. Here you see I have 3 SDN applications already set up. These are the guest management for the 3 dental clinics I have set up in the example. So I want to create another one for this restaurant. So I'm going to go ahead and create an activity. It's gone off to our API, and here you see my list of sites. So I'm going to pick the French restaurant, and here you see this virtual network I already created just a few seconds ago, and I'm going to apply the application to that existing virtual network. So now I've created a new application instance running on top of ODL, and now I'm going to go over and configure that application. So by default, here are our 4 applications currently supported in the system. This is the school application called Learning. We have a small business application called Working, Browsing, which is the guest management application, and Shopping, which is the retail application. So I'm going to create just a basic guest management application. I pick the logo for the customer. I give it a name. And I click Save. And now I can actually go configure the guest portal. Here's a snapshot of what the portal will look like. There's a number of different things I can set up here. One thing that's interesting is because we're using OpenFlow, everything about the implementation of the Captive Portal uses OpenFlow underneath. We have very fine-grained access to rules down on the end systems. We can actually allow you to put a guest network on the same VLAN as your staff network and then use OpenFlow as the way to separate those 2 out, so you don't actually have to create 2 VLANs down in the guest network. So our guests are not allowed to connect to anything on the local network. They can only get to the gateway, which is possible because that virtual network abstraction includes attributes for things like the IP subnet and the gateway and the DHCP ranges. So the OpenFlow application can know about what the gateway and all the attributes of the network are. So just a little tidbit of information about why we can do cool things by using OpenFlow. I'm going to set up email validation. This allows the user to get on the network for 15 minutes. It'll send that user an email at their email address. They will go check it. They'll click on the link, and it will authenticate them. And I will put them online for an hour afterwards, and then redirect them to Google when they are done. So now I am all done. If I go back to here, you can see I have a new application. If I go to the admin screen, this is where users would start popping up as I have users connect to guests. If you see them pop up, you would get a set of controls up here where you can actually kick them off the network, allow them on the network, change their validation period, things like that. And I can actually show you that, I believe. I come back here, go over to one of my existing ones, and you can see I have a user here. If I select them, I can put some comments in. I can authorize their session or deauthorize them if they're authorized. Here's where I manage all my guests. There's a number of other features here as well. So that's adding a new guest management application. So to review, right from this portal, I was able to create a new virtual network abstraction. I pushed that to actually just one site, and then I was able to set up a new application. It fired that up on top of Open Daylight. It connected that virtual network to that application, and it's off controlling the network. So that's part 1 of the demo. The next piece I want to show you is setting up a multi-site VPN using the Brocade Viata router as the firewall. So you can see here I have 3 dental clinics. I have a guest network set up on each one of those. So what I want to do is set up a staff network at each one, set up a virtual firewall, and connect those things all together. Now, this is a bit of a preview. Hopefully you can all see this. So to give an example of why those abstractions and APIs are important, this is actually a Perl script that I wrote in a couple of days that makes use of our APIs to make this all happen. So it's very amazing that once you create the right abstractions and the right APIs, how easy it gets to do very powerful things very reliably. So here I'm going to log into our cloud portal, but I'm just doing it from a command line. Again, on the back end, it's just calling our same REST APIs that web interface does. It's going to ask me for the customer name so it knows how to identify the instance. once I turn it up. When I do this, now it's going to select a VPN type. So I can do layer 2 or layer 3 VPN. We actually have the chiropractic clinic that uses L2 because they have some medical application that needs to be on the same broadcast domain across buildings. I'm actually going to use a layer 3 here. It's going to go off and start a new instance in AWS. While it's doing that, I'm going to go configure the attributes of the virtual networks. So first it's going to ask me where I want to put them. So I'm actually going to create 3 different ones. Again, I have a layer 3 VPN. So instead of creating one virtual network and pushing it to 3 sites, I'm going to create a specific virtual network because the IP address ranges are going to be different because I want to route between the sites. So I'm going to go to Bloomington. It's going to prompt me with some defaults. So these are all the attributes, or a subset of the attributes for a virtual network, the kind of key ones. So one's the subnet and the mask. It's going to prompt me with some defaults, which I'm just going to accept. The gateway address, the start of the DHCP range, the end of the range. And then it's going to, since I have Wi-Fi in this case, it's going to ask me for an SSID, and I'm just going to do that until staff. So there I created the first one for the Bloomington site. It's going to ask me to create another one. I'm going to put this one in Columbus. I'm going to accept the defaults. I'm going to give it the same name. It is a different VNet, but it'll be the same SSID name. And then I'm going to create a third one that I'm going to put in Terre Haute, and I'm going to do the same thing. Okay, so now I'm done creating my virtual networks. So now it's going to go off and do the provisioning. So it's started a firewall instance, and then it's going to load the actual Viata software onto that. This is going to take a few seconds, and just to go through what I'm doing while that does it. It's going to actually reach out, use the cloud orchestration APIs to turn that up. Again, this demo is going to use Amazon Web Services. I've created, it's going to go into use the REST API to our cloud to create that virtual network, those 3 virtual networks. It's going to push the LAN components of those virtual network attributes into in this case it's just Wi-Fi, into the access points at those 3 sites, and it's going to use the REST APIs to the Brocade Viata router to push the attributes that belong on the gateway to the Viata router. So things like the DHCP services, the NAT pools and such need to get pushed to this side. So it's going to do all of that. You can see that happening now. So it's going off and doing the first site. So it basically goes off. It has to turn on the REST APIs for the Viata. It generates certificates, so we're using encrypted tunnels back to the cloud. So it generates the certificates, and it has to push out those certificates. And now it's going to go off and actually push the VNet attributes down to the access points at the site and out to the gateway, which in this case is a Brocade Viata V router. And it's going to finish this up in just a second. When it gets done, it's going to say, just for the demo purposes, do you want to go ahead and log into that? I'm going to say yes, and it drops me into that Viata instance. Again, this instance is running into AWS. Since my sites are on the East Coast, it's running in the Northern Virginia area within AWS. So, for example, I can do show interfaces now, and you'll see I have 3 bridge interfaces set up, one for each of the sites. Those are backed by SSL VPN tunnels out to those sites. If I do show DHCP server leases, I don't have anyone yet. Actually, most times when I run the demo, it's amazing how fast someone finds an open Wi-Fi network. For the demo, I set these up as open SSIDs, and usually by this time, someone has jumped on and gotten a lease on one of those networks and made it go. Unfortunately, for this demo, they did not. But for example, I can show my NAT rules, and you'll see all the NAT is set up and running. If I were to jump on one of those SSIDs, you would see me show up with a lease here. Has anyone jumped on yet? Not yet. you would see me jump on, and they would all have be routed. So each of those gets their own subnet. There's internal routing between those private subnets, and then all that traffic gets NATed out to AWS from the Viata firewall. There's a lot more you can do here. The Brocade Viata vRouter can be orchestrated via direct REST API. It also supports netconf, so it can be orchestrated through the Open Daylight controller as well. For this demo, I happen to use the direct REST API. All of the same things can be done through the Open Daylight controller, and you can control large numbers of Viata vRouters through the Open Daylight controller. So there's a lot more you can do here. Every aspect of that of the vRouter is addressable through here. So lots of cool integrations to be done with the Viata vRouter going forward. This is sort of the tip of the iceberg, I think, that you're seeing here. So pretty cool. You can turn this all up, and it's all sort of integrated with that virtual network abstraction. If you come back over here and look at some of these sites, you can see that I now have the staff network set up. If you drill down into that, you'll see that it now has a backhaul type of an SSL VPN tunnel that is backhauling that virtual network over to the Brocade Viata. So all the components to tie those together, again, once you have a virtual network abstraction here and a gateway abstraction up here, it becomes very easy from a cloud perspective to start tying all those pieces together, both from an application standpoint and a virtual network services standpoint. So those are the sort of first two parts of the demo, and the last piece I want to show you today is an actual business application, so you can start seeing the value, that sort of second piece of value for the enterprise, which is business workflow integration. So to do that, I'm going to go to another customer site, which is called App Demo Land. This is pre-set up for a guest management, a school, and a small business application. Here's my learning application for schools. So this is focused to K-12, higher ed, primarily K-12. And it's, again, meant to be used by teachers and students in a classroom. So here you see the virtual network that's set up for that. I actually have an access point here in my office set up on it. Now I'm going to go back over to my SDN Activity Manager application and go to here, and here you can see those applications set up. This is the application instance for my classroom application. Now you can see here on my machine that I am actually associated with the App Demo Learning network right now. If I were to connect to that network like I have, and I have not logged in yet, the first thing I'm going to do is get redirected to a captive portal, in this case the Electronic Campus Classroom. So what I'm going to do first is I'm going to log in as the teacher. So this happens to be my teacher account. So I'm going to go ahead and log in as the teacher. So again, I've connected to a Wi-Fi SSID that has this application deployed. When I do that as a new user, it redirects me to a captive portal. When I log in, what I get as the teacher is the application. So we imagine this typically running on tablets, could be run on laptop, wherever you want to run it. I select a class. In this case, I'm a teacher for only one class called Software Startup. And these are the students that are registered in the student information system for that class. And I get a dashboard of what those students are doing online. If I were the student, I would come over through the magic of virtual machines, although I typed the password incorrectly. I have this virtual machine also connected through a different interface to that same virtual network. And when I come in as a student, again, I come to the same login screen in the captive portal, but I'm going to log in with the student ID instead. So I'm going to log in, click continue to the internet, and off I'm going. So as the teacher, first thing I'm going to do is pick a lesson. I can create a new lesson, or I can pick from an existing lesson plan. I want to pick a lesson. if you look at the lesson, it has a set of web resources associated with that lesson, and I can import more. There's various ways to get lessons into the lesson plan. But those are my resources that I have assigned as part of this lesson. I have controls for my lesson up here, so I'm going to start the lesson. Now, you see a countdown. It's by default set up for an hour-long class. So that's what the lesson is set up for. The controls here show me a couple of things. So I have two dots. The top solid dot is how much time out of the current lesson that student has spent looking at resources that are within lesson plan. In other words, how in focus have they been during this class session? And the bottom is, are they looking at those resources now? So I'm going to go over as the student, and I'm going to start poking around on the Open Daylight site, because this is part of my lesson for the day. And I'm going to see that here's the helium release being announced. I'm going to go into the getting started. I see there's a download. I'm going to go over and get the installation guide and start looking at it. So I'm going to start looking. There's a little bit of a delay here, but now you can see my user is during the session largely in focus, and he's currently looking at things that are in the lesson plan. This is averaged over, for the demo purposes, about 10 seconds, I believe. Now I'm going to come back, and he's going to go, well, I'm going to go over here and start looking at the news. I don't know what students look at these. This is what old people look at, I guess. And I'm going to look at tech news and for kids in Silicon Valley. Okay, I'm going to go up, new Galaxy S6. Maybe I'm going to get distracted and go over and do Grand. If I come back, again, there's about a 10-second delay here. This is going to start turning back to red the more time I spend here doing things that aren't in my plan for the day. It does take a little bit of time. In the classroom, typically, you're not going to be doing this within 5 or 10 seconds that I'm trying to do it in the demo. Trust me, there you go. He's now out of focus and over next refresh interval. That will go down as well. So the teacher can quickly go, hey, Jim here, what's Jim off doing? Jim's off in the weeds, probably looking at something else. So if I want to see what Jim's doing, I can go to the gear, pick a student overview, and I get an overview of where Jim's going, which is all over the page, right? Actually, the newest version we're going to push tonight does some nice summarization, all of this, that makes it a little less crazy. So, but I can see Jim's all over the place. So Jim's not going where I want to go, so let's go ahead and let's take Jim offline until I have a chance to walk over to Jim and put Jim back in order again. So now he goes over and tries to look at that Samsung Galaxy and goes, uh-oh, I've been caught. Now I'm not on the network anymore. So the teacher goes over to Jim, talks to Jim, gets Jim back in line, and can come back and say, let's put Jim back on the network again. And Jim comes back over to the network, and now he's going to go off looking at the things that he should really be looking at. And then the more he does that, obviously, he's going to go back to a green state over here. So key to point out, all the controls underneath, this is an application living on top of the Open Daylight controller. All the controls that are making all of this happen, here you can see it goes back, that are making this happen are done via OpenFlow. Whether it's rules to block Jim's machine from going anywhere, or it's rules to mirror certain parts of Jim's traffic so I can watch where Jim is going. All of those things are done through OpenFlow today, as well as, for example, the redirection to get to the login screen in the first place. There are a number of other things you can do in here. For example, if you want to do group-based learning, the teacher can do an auto group. They can say put 4 groups in each, 4 students in each group. And now I have groups, and I can track the overall group focus. In here, I can go in and I can either disband the group or disable internet access for the entire group at a time, or even just disband a group and work individually. Again, I can also disable internet access for the whole classroom. So, for example, a teacher wants to give it to class, wants to keep the students off the internet so they're not looking up what's going on in the class. you can do that too. So number of exciting things coming in the pipeline. You can start imagining all the kind of cool things you can do once you have this application in place. We're getting lots of great feedback from customers deploying this, and have a number of new features in the pipeline, some of which you can probably start guessing at yourself just from looking at this. I can then, obviously pause and stop the lesson. Pausing it requires stops tracking what's going on from a focus perspective. Stopping it just stops it. So that's the kind of business integration you can do. Integration with student information system to auto-populate the classes, the class schedule, the students per class. Integration with learning management systems to auto-build the lessons for the lesson plans. Integration with attendance systems. There's all sort of interesting integrations. And what ultimately happens is this becomes the center place of the workflow for teachers in the classroom. So if you think about sort of a whole new way to rethink network management, underneath a lot of the same sorts of mechanisms we've been using in the past in terms of implementing policy, but it gives us the flexibility, to deploy these applications over multiple vendors, hardware solutions through OpenFlow and Open Standard southbound APIs, and B, we're now looking to build applications that go in the hands of actual users that integrate with workflow in the workplace. So that's a summary. It looks like we're right about on schedule and have about 15 minutes, or if we want to go over more time after that, for questions. Does anyone have questions? I must have been extremely clear in my explanation of all this.
Actually, this is Amir. I do have a quick question.
Okay.
So this more looks like to me a scripting. So you have to be like a scripting guru versus network guru. Am I on the right track?
It depends. So obviously, our goal here is to make it so you do not have to do any scripting, right? Obviously, when adding these applications, for example, like I did here, and I want to create a new activity, behind the scenes, this is all going out and using REST APIs to do all of these things I do, to pick a site, to configure the virtual network, to push that into the network, to attach an application to that. Under the covers, it's using all the REST APIs. We don't expect the vast majority of our users to actually use us. The key is that, for example, when I showed the integration of turning up a vRouter instance in Amazon, we're able to deliver a solution faster and cheaper because we are working at a higher level on top of existing abstractions that we've created. So if we want to bring in another integration, that integration is easy to do. Now, we also have service providers using our solution that don't use this web interface at all. They have an existing portal that combines other aspects of their service, whether it be managed desktop or other aspects, applications of their service, that they simply use the REST API and integrate the whole network into a larger orchestration system with the rest of their solution. So if you have those capabilities, for example, as a service provider, you can take this solution and do great integration with existing systems. But the goal is that those don't have to be exposed to the customers. You can take a web interface we've developed or someone else has developed and use those.
So then for any integration, we have to be contacting you, right? Not in-house we should be able to do if we don't have those scripting capabilities with REST API.
Yeah, that would be correct. So we do a lot of that for customers as well. In fact, that's kind of part of our business is to build SDN applications and integrations for third parties, both customers, partners, and otherwise. So yeah, we also have the capability. If you're a service provider or an enterprise, and you go, wow, this looks really cool, but I want to integrate this with systems I already have, but I don't have I don't have people in-house that know how to do that integration, then absolutely we will work with you to do that custom integration or application development for you.
Do you have any environment where customer can go in and a little bit get familiar with it and play with it?
Yes, we absolutely do. We have something called an SDN starter kit that's actually gotten some press recently, and it's a small kit that involves a few APs, and you can take that and buy the kit and get off and going. And once you have that, you get an account in the system here. You get access to all the APIs, and you can get up and going with the system fairly quickly.
Outstanding. Thank you.
Matt, there was one question that was typed in the text box. You're using the Open Daylight controller is the one that you're using currently today instead of the Brocade one, but your plans are to port out all of this with using Brocade, right?
So underlying it's the exact same stuff. So the Brocade Viata controller is 100% based on the open source. It basically it's a tested, supported version of currently Open Daylight Helium SR2 release that has had some of the extraneous kind of components taken out of it. So it's identical to, we are running the identical code base to what's being run with the Brocade Viata router. So all those applications will run on that. Technically it's not running on the Brocade Viata controller today. The only difference really is we're not buying support and we're not using install scripts and getting all the advantages of sort of the developer support that Brocade provides around that. So it's really identical to the Viata controller.
Okay.
Hey Matt, this is Matt Bianco. You mentioned that you were running the Open Daylight controller as a cluster. Can you just talk about that a little bit?
Yeah, absolutely. So it runs in the cloud, and it's actually pretty interesting because we found it's architected such that it doesn't have to run in the cloud. We've specifically architected so we could run instances of that cluster in, say, a service provider's data center or an enterprise data center. But actually what we found is it actually works extremely well from the cloud. We have significant deployments of this running in the cloud, controlling equipment in multiple continents from multiple clouds, and it actually works extremely well. So let me bring that back up. So there's kind of two components to it. There's the scale-out clustering mechanism. So basically load balancing, intelligent load balancing, so we can have multiple instances of Open Daylight running at the same time to handle load across a lot of different customers. So that's sort of one piece that we've added kind of under Open Daylight. And the piece we've added over is what's called a virtualization layer. Actually, a couple of key pieces to this. It's actually a fairly big bit of work. So it does a couple of things. So one, it allows us to really make each of those instances of Open Daylight be multiple tenants. So we can have a school app deployed to one customer site, a store app to another customer site, and a guest app to a third customer site that all end up running on the same controller. So there's that piece of it. There's also a REST API that creates the higher level policy abstraction. Which allows us to do this sort of rich functionality you kind of see in the K-12 app. So that's a piece of that virtualization layer as well. And it also knows how to query that network abstraction that we have for the virtual network. So the app can actually know, actually the virtualization layer can actually know and tell the app for a given virtual network, here's the other attributes like the subnet, the gateway, the DHCP ranges. And so it's kind of cool because then the application can take those things into account. So for example, in guest management, we can put our guests on the same VLAN as the staff users, but then have it put open flow rules and only allow that guest to get to the IP address of the gateway. So that's the clustering mechanism. It runs in the cloud, public cloud today. and it scales out, and that's ultimately what allowed me to do, create a new app, and it will spin up a new instance if needed to handle the load. It can put additional apps on top of that. So that's sort of the key to what we're doing on the Open Daylight side.
I had another question specifically about that education app. Where does the correlation go between? So I think you said you were mirroring in order to see that a student is going to a particular website, whether it's on task or off task. That traffic's being mirrored somewhere. Where does the correlation actually occur to know whether that's on task or off task?
Yeah. So that list, actually, I stopped the lesson so I can't see it. So it happens in a couple of places. So what happens ultimately is that school app is using OpenFlow through Open Daylight to basically intelligently mirror portions of that user's traffic over a tunnel back to a portion of the application, essentially, where that correlation takes place. So it basically is very selectively taking packets and putting OpenFlow rules that both forward the traffic as well as make a copy of the traffic and send it through a tunnel back to the app, where the app can then correlate that with the other information it knows, such as the MAC addresses of all the users and the lesson plans and all that stuff.
So one other question specifically with regards to the cloud aspect of this. What if you lost connectivity to the Open Daylight controller? What happens at the site? Does it continue to forward traffic based on the rules that are already applied? Do they time out? How does that kind of work?
Yeah, it depends on the application. It depends on how you've set it up. So for example, we have a few different failover modes. So we make heavy use of what's called the forward normal action in OpenFlow. And you can actually run a VNet at a site with no OpenFlow, with everything forward completely normal. So lots of use of hybrid mode down here. So for example, on the guest management application, there are a few different failure scenarios. So one scenario is the fail close scenario. So if the devices lose access to the application, it will basically block all access. So that's sort of a secure failure mode. So that's one option. The other option is sort of to leave the existing rules in place, so guests who already authenticated to the capture forward will keep working, but the new guests actually get redirected. There's a mechanism to redirect them to a locally hosted web page on the device that says, sorry, the login screen's down right now. You'll have to come back later to log in, but the existing traffic all keeps going. The last option is a fail open option, which the network just becomes an open network and everyone gets on, and there's no tracking of those. So all of those mechanisms are possible. Obviously, in the school application scenario, you would lose all of those controls should it go down. So if you lose access, obviously you have no way to control where the students are going. Again, you could leave the existing rules in place, and things would keep operating as normal until the connectivity came back up, or you could fail open or fail close. So those are all options with the different applications. So as I said, it's obviously why we architected the system such that this component could live either in the cloud, in a private cloud, or a server somewhere. We often, when we demo at a conference, we'll bring a server along and we'll run this local to the site. Works just as well.
Okay, thank you.
Any other questions? Okay. Well, thank you everybody for joining us this morning. Please follow up with your Brocade representatives with any additional questions you might have. And Matt, do you have your contact information you would like to share with people?
Oh, that's a very good thing. Yes, I didn't have that hand. Since I have a screen up, it's simply mpd@tallac.com.
Perfect. Perfect. Thank you, Matt. We really appreciate it, and I think we've all gotten a little dose of how this is now reality for us. So thank you, and have a great day.
Yep. Thank you for everyone for joining.